Hi, hello everyone. Good evening. This is your Ameer sir, Master Teacher of Physics at Vedantu. Now I'm waiting for everyone to tell me how are you all doing. I know that it was an amazing day, but if I can listen to from you, right, that you all are doing good, it's gonna be so much awesome. So hi there, Nika. Good evening. So how was the day and how is your revision plans going on? Are you able to continue according to the timetable whichever you're making? Hi Vedika, good evening. Good evening. Good. Okay. Yes, I'm doing super good. It was an amazing day for me. So I'm so great. Now waiting for every one of you to tell me how the day was. Anyway, here we are with the Rapid Sprint 2.0 and welcome you all to another session of Rapid Sprint 2.0. And as we all know, we have completed a lot many topics, right? Which means electric field, potential, capacitors, current electricity, and magnetic field. Sorry, magnetic effect till now. I hope you have gone through all these topics. If any one of you have missed any of these topics, it's still available in our channel. Go and watch it because we have discussed amazing questions from these topics. So I don't want any one of you to miss this, right? So hi, hello Fishan. So I think you are new to the session, right? Yes, I'm going to do it, Dharaniga, so soon. Don't worry. Maybe next week. So I'm going to do that. So don't worry at all. Fine. Okay. So today we are with another topic of magnetism, and we are going to solve as many questions as possible from this particular topic. Okay. So I hope you all are ready. I hope you are so much energetic for the same. Okay. Just like you do all the time. Okay, so Fishan, tell me how this session was and how much you have learned at the end of the session. I'll be so happy to know that. Okay, so an honest feedback will always make me happy. Okay, so moving on. So if anyone is new, just like we have Fishan in the classroom, so I think you don't want to miss any of the classes which is being held in the channel of Momentum with Vedantu. So now itself, move your cursor. Okay, I don't want any one of you to be lazy because we have a lot much to learn also. So be an energetic and exciting student. Move your cursor now itself. Click on that red subscribe button. You all did what? Right? So I hope you did that. Now, one more thing that I want to tell you is, okay, whatever questions we are discussing today, it will be uploaded in our Telegram group before this session happens so that you can all have a look at the question before you actually come to the session. Fine. So because you can actually prepare and whatever doubts you have from the question, we can discuss it together here. So that's a big opportunity. So I think you all are going to make use of this opportunity and be a part of this Telegram group. And one last thing, we all know that we are just 30 days away from our JEE mains exam, which is going to happen, right? So in this 30 days, the crash course which we have started by the Vedantu, we are planning to complete all the concept and most of the questions from these entire syllabus, right? So that we are going to complete, so that we're going to crack the entire JEE mains. So what you want to do is you can come and join the crash course if you feel like you need a personal mentoring where you wanted to complete all your concept, okay, and you think that you want to do lot much of questions from this particular part, okay, and you also wanted to do an all India level mock test. So this is the best chance. Come and join the Vedantu fast track crash courses where you can get the best out of you and there is a best way, okay, so that you can crack the upcoming JEE exam. So for all these things, I'm giving you a coupon code and the link is below. Click on the link, apply the coupon code and get this crash course just for 8,000 rupees. Fine. Now it's time for our physics. What do you all say? Shall we start with the very first question? Everyone, Vedika, Fishan, Dharnika, are you all ready for that? Are you already a what? Yes. Hi, Tornado. The last class, I think you left so early. What happened? I think everything is good and you have watched the replay of whichever part you have missed. So yes, we are moving with the very first question as you can see right in front of you. It goes like this. The cohesivity of a small magnet where the ferromagnet get demagnetized is 3 into 10 power 3 ampere meter, right? Okay. The current required to be passed in a solenoid of length 10 centimeter and number of turns 100 so that the magnet get demagnetized when inside the solenoid is. I'll explain the entire question to you. So everyone listen. Okay. Now, what do you mean by cohesivity? Cohesivity means the intensity of the external magnetizing field that has to be applied on a magnet in order to demagnetize it, okay, to convert a magnet into a normal material. How much of intensity of external magnetizing field has to be applied is what we call it by the name of what? The cohesivity. Okay, we usually write it by the letter of H, that is 3 into 10 power 3. So the amount of H that has to be provided is equal to 3 into 10 power minus 3. So for providing this external magnetizing field, what we are using? We are using a solenoid in order to magnetize this particular ferromagnet, which means the magnetic field has to be provided by the solenoid. What is the value for magnetic field provided by the solenoid? What is the formula? That is equal to mu naught times Ni. Okay, so mu naught times Ni is the value for magnetic field produced by this particular solenoid, and the produced magnetic field should be sufficient enough to give an H value of 3 into 10 power 3. Okay, so if an H value of 3 into 10 power 3 has to be provided, what should be the magnetic field that has to be given? So the relationship between magnetic field and H is equal to mu naught times H. B is equal to mu naught times H, and the B value is given as what? Mu naught Ni, which is provided by what? Which is provided by, who's actually providing this? This is being provided by the solenoid, is equal to mu naught H. Mu naught cancelled. N, small n means what? The number of turns per unit length. How will you calculate it? Total number of turns by total number of length into I is equal to H. The thing what has to be found out is a current, right? So let's start substituting. N is equal to 100. We have the value for L is equal to 10 centimeters, which can be written as 0.1 into I is equal to H, that is equal to 3 into 10 power 3. 100 by 0.1, 10 power 3s. Both the 10 power 3s cancel on both the sides. We'll have the value for current as 3 ampere. Understood? So which option we can go for? Which option we can go for? We can go with the option A as our answer. So we have Kaushika already gave me the correct answer. Very good. Okay, so keep it up. So everyone be like Kaushika and be so much energetic, because I just mentioned her name because she's so excited. I can see that. Okay, because she was doing the problem before me. That's very good. Okay, Tornado, here we have very good Tornado. So it is the option A, which is 3 ampere. Is it clear to everyone whatever topics we have discussed on this particular question? Is it clear? Everyone? Yes, no, yes. So I'm gonna move to the next question, hoping that no one is having any of the doubts regarding this question which we have discussed. Here we have another. Very good, Kaushika, very good. Vishal, yes, very good, amazing. Okay, so yes, keep up the Josh high, okay, which means be more energetic. So here we go for the next. A circular coil of n turns and radius r carries a current I. Okay, so we have a circular coil of n turns are there, its radius is r. It is unwound and rewounded to make another coil of radius r by 2. The current I remaining the same. Calculate the ratio of magnetic moment, the magnetic dipole moment, right, of the new coil and the original coil. So let's start from the beginning. Now we know that a current carrying circular coil will be acting like a magnetic dipole, and the value for magnetic dipole moment M produced by the current carrying circular coil is given by the formula of N times I into A, right? Total number of turns into current passing through it into area. So first let us find out the magnetic dipole moment of the original coil. O let us write, which means initially. Total number of turns is N, current is I, area is equal to pi r square, because it is circular coil, area is pi r square, no doubt. Now, what is happening? The question is also to find out the new value. Okay, so the new magnetic dipole moment value. How will you calculate? That is equal to the new number of turns, which we don't know. Let us put it as n dash. Current is the same. Let's put it as I. Okay, and what is happening to the radius? R by 2. So area is equal to pi r by 2 the whole square. Is it clear this part? Now the only unknown which is stopping us from getting the correct answer is n dash. How will we get? You have to know that it is the same length of the wire which is being rewound. So in both the cases, the length in the first case, okay, and the length in the second case for the wire will be the same. For one complete turn, the length of the wire will be equal to its circumference, that is 2 pi r. Initially, there are n number of turns, so total length in the initial case is n times 2 pi r. So how will you write the length in the second case? The number of turns, that is n dash, into the circumference of each of the coil, that is 2 pi into r by 2. Why r by 2? The radius is half. It has been given in the question. Now, if you can look, you will get that 2 pi r will cancel, n dash will be equal to 2 times n, which means the number of turns have actually doubled. So while you substitute the value here, n dash is equal to 2 times n I pi r square by 2 square is 4, right? So 2 by 4 is 1 by 2. Then what do you have? N I pi r square. What is n I pi r square? That is the original value for magnetic dipole moment. So the new value for magnetic dipole moment Mn is equal to half the value for original. The question is the ratio of new coil Mn divided by Mo, that is 1 by 2, which is the option. Option A is what you're going to get. How was that, everyone? Tell me. So I think it was covering, okay, I think it was covering maximum theory. We discussed maximum theory from the question also, from this chapter also, because we tried, okay, actually I tried to cover the theory of magnetic dipole moment through this particular question. So have you understood all the concept that we have discussed and the method by which we have solved this problem? Is it clear? Okay, so Kaushika already gave the answer. 1:2. Very good. Others? Is the area changes? Yes, the area is changing obviously because the radius is becoming half. Now I hope you understood. Yes, Vijay, we are going to do with the theory as soon as possible. Yep, so no doubts are there. Okay, so everyone is smiling just like me out there. And tell me, sir, go for the next question. Yes, very good. That's the spirit. Here we move to the next. Uh, yes, Vijay, don't worry, I'm gonna do it. So we have Vijay and Vijayan all the time for the theoretical class. Let me plan one soon. Okay, so here you know that the schedules has to be because I have a lot many other class. So I'll try my level best to start with a new course. Okay, fine. Sure, sure. I'm gonna do it. We are gonna do it. I'm there with you. So what about now? Shall we start continuing with the problem solving? Don't worry. Along with this question, I'm going to explain all the related theory to it. Very good, Kaushika. Okay. Yes, we are gonna do it to Tirunagain, Robert. Robert, that's a very good name. So here we go. Now, the Earth's magnetic field lines resemble that of a dipole moment, right? Which means the magnetic field lines of Earth is exactly acting like, right? A bar magnet is kept well inside the center of the Earth, or well inside the Earth, right? I hope you all have learned that. If you want a more explanation, let's say this is the Earth, right? It feels like, if this is the geographic north and geographic south, it feels like a bar magnet is kept inside the Earth, right? Where north pole of the magnet is at the geographic south and south pole of the magnet is at the geographic north. And the field lines of the Earth are exactly behaving in the same way, in such a way that a bar magnet is kept well inside the Earth. Don't think that there is a bar magnet kept. It feels like, according to the magnetic field lines produced by the Earth, it feels like. That's all. Okay. Now, the magnetic dipole moment of this assumed bar magnet kept well inside the Earth is given with the value of 8 into 10 power 22. Question is the value of the Earth's magnetic field near to the equator. Okay, so you all know if you are having a magnetic dipole, right? If you are having a magnetic dipole, the value for magnetic field at a distance of r is given by what's the value? Can anyone tell me? Kaushika, Vichai, Arun, Robert, who is there? Tornado, Tirnakan, who is there to give me the answer for that? Magnetic field is mu naught divided by 4 pi, then 2 times magnetic dipole moment by r cube, isn't it? Very good. So you just have to put the values here. That's it. So what is the value for mu naught by 4 pi? It is 10 power minus 7. 2 times magnetic dipole moment. It's 8 into 10 power 22. The whole divided by r cube. What is the radius? R means the distance from the bar magnet to the point. What is it given as? 6.4 into 10 power 6. So 6.4 into 10 power 6, the whole cube, right? So the answer which we are going to get is, what's the answer we're going to get? We'll be getting it as 0.6 into 10 power minus 4 Tesla. 10 power minus 4 Tesla is equal to 1 Gauss. So this is 0.1 Gauss. Is it clear? Which means we'll be getting the option as C. Is it clear to everyone in the classroom? Any doubts? If you have, it's a time that you are going to ask me all those doubts. Yes, the answer is 0.6. So Tornado, it's clear. Very good. Kaushika gave the answer. Great. Vishal, no, so no doubts are there. So now here we are with another question. Great, great, great. Very good. So all are doing your level best. I'm so happy for that. So I hope everyone, whoever is listening to this classroom is having a pen and a book along with you, right? So that you can work out all the problems, whatever we are discussing it here. Okay. So it's going to help you a lot. Okay. Here we go. Two magnets, each of dipole moment are aligned with each other at an angle of 60 degrees. Okay, with the unlike poles together, then the dipole moment of the combination. So here you can see two magnets. Okay, the dipole moment of the magnet is always directed from the south to north, and each is having a magnetic dipole moment of m. This is another magnet. Dipole moment is also from south to north with a magnitude of m. So now we have two vector of same magnitude m by an angle of 60 degree. How will you find out the resultant magnetic dipole moment? This question became that simple. What is it? Root of m square plus m square 2m into m into cos of 60. Finding out the resultant of two vector, you all know that if a and b are vectors which is having an angle of theta between them, the resultant is root of a square plus b square plus 2ab cos theta. Now this is m square plus m square is 2m square. 2m square into cos 60 is 1 by 2. 2 cancel, so 1 more m square. So this is root of 3m square. 3m square. M square will come out as m root 3. Simple. Simple, yes or no? Wasn't it simple? Right? Because this is, I think, from all the questions that we have discussed till now, I think this is the simplest one. If you know something such as a magnetic dipole moment is a vector, it is directed from south to pole, right? Okay. If you know this, simply by applying the concept of vectors, the answer will be in your hand. So if you have any doubts, you can ask me now, or else let us jump to the next part. Okay, so I think no doubts are there from anyone, so it's time we move. So where we have reached? An electron revolving in an orbit of radius 0.5 Armstrong in a hydrogen atom execute 10 revolutions per second. So the radius is given as 0.5 into 10 power minus 10 meter. Armstrongs to meters. Okay. It executes 10 revolutions per second. So the frequency is given as 10 hertz. Done. Find the magnetic dipole moment of an electron due to this orbital motion. From where this concept of magnetic dipole moment is coming. I hope you all remember, if you are having a current carrying loop, right? it is acting as a bar magnet, or it will be associated with a magnetic dipole moment. We know this. Now, in the same scenario, if a charge is moving in a circular path, isn't it similar to a current in a circular path or current in a closed circular circuit, right? The flow of charges is simply defined as current. So, if a current in a closed circular path can be acting as a magnetic dipole, okay, the charge which is moving in a circular path, right, where the flow of the charge itself is called as the current, right? So a charge flowing in a circular path can also produce what? A magnetic dipole moment. That's it. And what is the value of magnetic dipole moment produced? Q V R divided by 2. Okay, so the value of magnetic dipole moment is equal to QVR by 2. But here everything is written in terms of frequency. So let's try to introduce. So this is Q into R, Q into R. You know that the velocity is related to angular velocity as R omega. So I'm going to write it as R omega by 2. So Q R square omega is equal to 2 pi into frequency by 2. So 2 cancels. What can you write? Let me write it here. So the magnetic dipole moment is equal to Q R square F pi. Any doubt in this? Now what is only left is applying the values or substituting the numericals here. That's all. Once you do that, this question is done. So what do we have? It's an electron. The charge of an electron is 1.6 into 10 power minus 19. R is 0.5, that is 1 by 2. Square is 1 by 4. 10 power minus 10. Square R is being squared here. So that is equal to 10 power minus 20. Done. Then what do we have? Then R square F is equal to how much? 10. Okay. Then again pi is equal to 3.14. So I know that you all are super good in the calculations. Yes or no? Yes. So the answer that you're going to get is option A. That is 1256 into 10 power minus 41, and the unit is ampere meter square. It is going to be 1256 into 10 power minus 41. Because you look, this is already 10 power minus 20, this is 10 power minus 19, that is 10 power minus 39, it is already. Okay, then what we have is 1.6 by 4, 10, 3.14. While we do it, what we'll be getting is 1.2 converting into 41, that is 1256 into 10 power minus 41. Okay, so but I'm so happy, Kaushika, you are really trying out from there. I know that everyone is trying out from there, so I hope all the topics what you have discussed till now it's clear to you. Any doubts? No? Yes? So till now, I think every questions and all the theories what we have discussed is clear to everyone. Everyone is smiling out there, okay, on the thought that yes, we have covered these many theories and these many questions from this chapter, right? So I'm so happy to spend this evening with you. I hope you also feel the same, okay, and you think, okay, I think that you all have made an really amazing attempt to crack the JEE by being here. Okay, yes. So thank you so much. Now, what I want to tell you is if any new joinees are there in the classroom and if you have loved this particular class, what do you have to do? Can you just move your cursor right now? Okay, and can you click on that like button and let me know that yes, you love the classroom, and you can share it with your friends also. Once you come to the next classroom, take your friends also so that she or he can also learn these topics. Fine. And I think I don't have to talk about a third one because I know that you really don't want to miss any of these classes, right? That is happening live from the channel of Momentum with Vedantu. So please now itself move your cursor, hit the subscribe button, and that will be a great compliment for all of us for what we are doing for every one of you. Okay, so yes, thank you so much, Vishan. Thank you so much, Kaushika. It was an amazing session with everyone. Okay, so till we meet next time, bye everyone, and take care.